Hey everybody, this lesson is part two. It's called inverse variation. So it's real similar to the direct variation that we did before. There's direct variation, y equals kx. Inverse variation is y equals k over x. Okay, so the only difference is the k goes on top and the x goes on bottom. Now, in nature, what direct variation does is as one thing goes up, it makes the other thing go up. Like, for example, the older somebody gets, the you increase in numbers, then the taller they get or the heavier they get in general. You guys, there's always exceptions. Inverse variation is when one thing goes up, it makes the other thing go down. Like for example, the more I increase my speed as my speedometer goes up higher and higher, then the less time it's going to take me to get there. So that would be an example of inverse variation. Okay, so when one goes up and the other one goes up, it's direct variation. And when one goes up and the other one goes down, that's inverse variation. Okay, both of them, k is the constant of variation. And k can't be zero. Okay, so tell whether the equation represents direct variation, inverse variation, or neither. And then if they are direct or inverse, find k. Okay, here we go. There's those three examples right there. And so both of these are in terms of y equals. So let's go ahead and solve for y. Sorry for a little brain freeze right there. So I'm going to solve each one for y. So here's number one. Divide both sides by x right there. So we get y equals 7 over x. Okay, this is an example of inverse variation right here. See, it's in the form of y equals k over x. So it's inverse variation where k is the 7 right there. Can you see the 7's in the place right there? So when we divide both sides by x, it gives us an inverse variation. Okay, how about this one? Solve for y. Okay, so here I'm going to multiply both sides by y to get it out of the denominator. Okay, so I get x equals 2y. And then divide both sides by 2, okay, or I'm sorry, the symmetric property, flip it around the equal sign, that's called the symmetric property, sorry. And then now divide both sides by 2, and we get y equals 1/2 x, okay? Which one does it look like? Well, that looks like it's direct variation, y equals kx, where k is that 1/2, okay? So this one's direct variation, okay? K is 1/2, all right. How about this one here? Well, most of you guys know from today's lesson, you guys know that this one's neither, but if we solve for y, subtract 3x, and then divide everything by a -1, and so you get y equals 3x minus 5. That one's neither, you guys. It's not an any form. It's because of this -5 right here. It's got to be a +0 right there. Okay, I think we're going to graph next. Yeah, here we go. So graph y equals 4 over x. All right, let's go back to our old school and set up a table, you guys. These are how, this one, now what is this, you guys? Is it direct or is it inverse? This one's inverse right here. So inverse, remember direct made a line that went through the origin from the last lesson. Remember the line going straight through the origin? This one's not a line, you'll see in just a second. All right, so I'm going to plug in -4 right there. So it's going to be 4 over -4. So 4 over -4 is -1. So here's the point right here at -4, -1. Okay, now let's plug in -2. -2 is going to go right there. Okay, so it's going to be 4 over -2. 4 over -2 is -2. So here's the point, -2, -2 right there. Okay, and then we'll plug in -1. 4 over -1 is -4. So here's the point, -1, comma, -4. Okay, it's this disordered pair, -1, 4. All right, when we plug in 0, you can't have 0 in the denominator, so this is undefined. So we're not going to, that can't be graphed right there. And then when we plug in, 1, 4 over 1 is 4. 4 over 2 is 2, and then 4 over this 1 is, 4 over 4 is 1. Okay, so I'm going to graph 1, 4. Here's 1, 4 over 1 up 4, 2, 2, and then finally here's the 4 comma 1 right there. Okay, so what happens on these inverse, now if I did, let's just try 8, you guys. Think about 8 way over here. 8 would be right about right here, you guys. If we plugged in 8, 4 over 8, that would be a half, you guys. So if I did 8, it would just go up just a little bit. And what happens is it makes kind of a curvy kind of graph, and it goes towards the axes right here. It'll never cross them. They call it asymptotically going towards the these axes right here, and these axes are called asymptotes. So you don't have to worry about that. But that's what they're called. You'll worry about more of that in Algebra 2. Okay, let's try it with this guy here. So now it's y equals negative 4 over x. Let's see what happens to this, you guys. So I'm going to plug in negative 4. So negative 4 over negative 4, I should get positive 1 right there. Okay, when I plug in negative 2 and negative 1, it's giving me these points, these positive points. So here's negative 4, 1, here's negative 2, 2, and then here's the negative 1, 4. So this one's going like this, okay? And then it's still undefined at 0 because you can't have any number over 0. So it's undefined there. So when I plug in those, it's going to give me all the negatives, okay? So what happens is that negative, remember the other one was down here and it reflected it up here. And then this one in the other graph was up here and it reflected it over here. So this negative makes it reflect over this x-axis right here, okay? And that's what an inverse graph looks like. It's either going to look like that or it's going to look like this guy right here, that one, okay? Here's y equals 4 over x. Okay, so they're going to be looking like that or like this guy right here, okay? All right, what else do we have? So y varies inversely with x. Write an inverse equation that relates x and y, then find y when x equals 2. Okay. All right, so here's number 1. Y equals 6 when x equals 3. Remember, inverse variation equations, that's kind of hard to say. They look like this. Y equals k over x. Okay, so we're going to substitute in 6 for y, and x is negative 3 right there. Okay. So there we go. Substitute those in, and then we're going to go ahead and multiply both sides by that denominator to get rid of it, and we get k equals negative 18. So that's going to go right there, okay? So we're going to go ahead and plug that in right there, and we get y equals negative 18 over x. Okay, there's the first part, said write an inverse equation. So that's the first part. This is a 2 answer. And then find y when x equals 2. So I'm going to plug in x equals 2 right there, and we get y equals negative 9. Okay, let's try one more of these. Okay, so x equals negative 6 and y equals negative 4. Remember, there's our equation. So let's go ahead and substitute x equals negative 6. That goes down here, and y equals negative 4. Here we're going to multiply both sides by negative 6, and we get 24. So k equals 24, so there's the equation. Plug in y equals 2, I'm sorry, x equals 2, and find y equals 12 right there. All right, you guys, if you're in my class, that would be your homework assignment right there. Take care.